Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about graphing linear equations. A couple things I want to point out. First is our standard form, which is right here. So our standard form for a linear equation is y equals mx plus b. And there's some key parts that we want to point out in this equation. The first one being m. M stands for the slope. And the slope is like our GPS of the equation. So it tells us how to move, right? Are we going to move up, down, left, or right? And how many in each direction? Our slope helps us figure that out. The other really important part for our purpose today is B. B is our y-intercept. Our y-intercept is really the starting point of where we graph. So we actually start here and then we move to the slope. So we put our starting point and then we say, okay, now how do I move from there? X is our independent variable and y is our dependent variable. And we can put different values in for x and y, and we do that in other tasks. In this video though, they're just gonna stay x and y. The last thing I want to point out before we actually go in to start graphing some equations is what the slope is. So I know I mentioned over here, our slope is like our GPS. Tells us from our starting point how to move. And specifically, slope is always in the form rise over run. And what that means is the value that's in the top of the fraction is our rise, meaning it tells us how to move either up or down, how many units to move up or down. Our run, which is in the denominator of the fraction, is our run left and right. So it tells us how many units to move either left or right. If we have a positive number in the numerator, then we're moving up. If we have a negative number in the numerator, we're moving down. And then in the denominator, if we have a positive number, we move to the right. And if we have a negative number, we move to the left. In this first example, we've got y equals 2x plus 1. The first thing we want to check when we look at this problem is it in the right form? Remember, we said standard form for a linear equation is y equals mx plus b. And the values could be positive or negative, and that's fine, but it needs to be in this form. When I look at this, I just read it to myself. I just think y equals mx plus b. Okay, yeah, it's in the right form. It is important that the y is alone. So when we notice this, the coefficient in front of the y, the number in front of the y, is an understood 1, which means that y is alone. When we look at this problem, we want to identify the y-intercept first. Remember, that's our starting point. So when I look at this, our y-intercept is going to be our b value. It's the value that does not have an x with it. It's called the constant. It's just a number with no letter beside it. In this case, that's a positive 1. So that means our y-intercept is a positive 1. Our slope, remember, the slope is the m value, and it's the coefficient of the x. It's right in front of the x. So when we find our x, the number right in front of it is 2, and it's a positive 2. There's not a negative sign out front. It's a positive 2. So that means our slope is 2. Now here's the thing. When we figure out slope, it's easiest, if we're going to be graphing, it's easiest to write slope as a fraction. Remember, we said up here that slope is rise over run. It's in fraction form, and it's just a little easier to see what's going on. And 2 right now is not written as a fraction. However, I can easily make it a fraction. I can make anything a fraction by putting it over a positive 1. So 2 and 2 over 1 are the same thing. It's better to see it in this form when we're graphing, and you'll see why in a little bit. It's going to make it easier. One other quick thing I want to point out, notice I did not say that the slope was 2x, right? That's a very common mistake. It is tied to the slope through multiplication, but it is not part of the slope. Now that we have our y-intercept and our slope laid out, we're actually ready to graph. Our y-intercept being our starting point is going to be the place where we start on the y-axis. That's why it's called the y-intercept. So if our y-intercept is +1, then we graph our first point where y is +1. So now we can use our slope, our GPS, to help us figure out where to move from that point. And that's where this information is going to come in handy. So if we've got a numerator of +2, well, remember our numerator is our rise, that's our up and down. And if it's positive, that means we're moving up. So this is really 2 units up. The denominator of +1, remember, our denominator is our run, our right and left. And if it's a positive number, it's right. So that means we're moving 1 unit to the right. So we can move from there using our GPS. So from this starting point, we're going to move 2 units up, 1, 2, 1 to the right. So from this point, we can move again, 2 up, 1 right. In the same way that we moved +2 over +1, we could also move -2 over -1. And let's think about what direction that would move us in. So if it's a -2 up top, that means down because it's negative. So we're moving 2 down, 2 units down. And if we've got a negative in the bottom, well, a negative in the bottom means left. So we're moving left 1 unit. And what's cool is we'll see that this actually falls on the same line. If I go back to the starting place, which was at +1, our y-intercept, and I go back there and I move now down 2, left 1, do you see how that falls on the same line that we've created? And we could keep going. So from here, down 2, left 1, down 2, left 1, and so on until you're out of space. It should all fall on the same line. So the reason that this works is because +2 over +1 is the exact same thing as -2 over -1. And I can prove it to you on a calculator. So if I said -2 divided by -1, it's the same thing as 2, which was originally our slope, right? We just put a 1 underneath it, +2 over +1. Because those values are the same, they're just written a different way, that's how it falls on the same line. Notice that when I connected those dots, I didn't stop here and here. You want to extend the line and make sure you put arrows on either side, because at the end of the day, this is a line. It is a linear equation. It's going to stretch forever in each direction. In our next example, we've got y equals -3/4 x plus 3. For this one, the first thing we want to ask is it in the right form? Y equals mx plus b. And you might be thinking, is it okay that m was already a fraction and that it's negative? 100%, that's fine. So yes, this one is in the right form and our y is alone, which is so important. So the first thing we want to identify is our y-intercept, our b value, which in this case is a +3. So we'll go ahead and note that y-intercept is +3. Our slope, in this case our m value, which is right in front of the x, is a -3/4. It's already in the form of a fraction, which is great. So we do want to make sure we include that sign. Now, what's interesting, you may have noticed that my negative is kind of going with the 3 up top. When you have a negative and then a fraction, that negative can go with the top or the bottom. So let me show you what I mean. And I'm going to write it just up here in the corner. We could have a -3/4 with a negative just kind of out on the side, not really going with the top or the bottom. And that's fine. That's kind of what we saw here. We could also write this as, this is equal to a -3/4. So far, these two say the exact same thing. We could also move that negative to the bottom. I could say +3/-4. All of these are equivalent. Now, what is not equivalent would be to split the negative and have, I'm going to say it is not equal to a -3/-4. That would be different. That would reduce to a positive, which would be like this situation that we saw here. Just important to understand that each of these 3 things on the top all say the same thing, and we'll see all of them. I kind of just naturally wrote that negative with the 3 in the numerator, so we'll go with that for now. When we identify this slope, we're going to say the -3, I'm going to make sure I show that negative is in the numerator. -3 means that we're going to move down 3 units. So 3 down. And the +4 means we're going to be moving to the right. So we're going to say 4 right. Our y-intercept is our starting point at +3. And then from there, we're going to move 3 down, 4 to the right. And I don't have quite enough room to go again, so that's okay. I only got 1 additional point. But remember, we can also move in the other direction as well. In the same way that we could go 3 down and 4 right, I could move that negative to the 4, make the 3 positive, and I could say 3 up and 4 left. 3 up and 4 left. And notice it falls on the same line. As a quick side note, notice that our slope in our first example was positive, and we created a positive slope line. And our slope in our second problem was negative, which created a negative slope line. That's always a good way to just double check yourself. Make sure that your line, if it has a negative slope, that it's moving down, and if it has a positive slope, that it is moving up. And what I mean by down and up, I know that can be confusing because we do have arrows on each side, but if we read this graph like a book, left to right, and as I move left to right, do you see how my line's moving down? That's a good way to tell. For our next example, we've got y equals -x minus 2. So hopefully you're getting a little bit more comfortable with identifying the y-intercept. Remember, that's our constant. And in this case, it's a -2. We want to make sure we include that sign. -2. Our slope is a little harder to see here, and you may be thinking, well, there isn't a number in front of the x. And there actually is. We have a negative sign, so we'll make sure we remember that our slope is negative, but there is an understood 1 in between that negative and that x. Anytime that we don't have a number in front of a letter, a variable, it's an understood 1. So in this case, our slope is a understood -1. And remember, we really like slope to be in fraction form. And I can make that -1 a fraction by just putting it over +1. So for our movement, we've got a negative in the numerator, which tells us we're moving 1 unit down, and a positive in the denominator, which means we're moving 1 unit right. graphing at our starting point of -2, so we want to find -2 on the y-axis, which would be right here. And then how do we move from there? 1 down, 1 right. So 1 down, 1 right. And then in the same way, we could also move 1 up and 1 left. From back at the starting point, 1 up, 1 left. Let's look at another couple examples. I've written a reminder up here of our standard form y equals mx plus b. And when I look at this first problem, this says 2 times y equals 1/2 x minus 10. Well, we haven't had a 2 or any number in front of the y before. And that's really important because what that means is that this, even though it's really close to being in standard form, it doesn't quite fit because of that 2. Even though we've got our mx plus b and that part looks fine, the 2 throws it off. So we're going to use our inverse operations. We cannot graph this until this is in the correct standard form. If this is 2 times y, well, we can undo multiplication by using division. And we want to divide by what we want to get rid of. So in this case, the 2. I want to get rid of the 2, so I divide by 2. And what happens is here, 2 divided by 2 is a positive 1, which will leave us with just 1y, or just y. And that's exactly what we want. So these 2's actually cancel to 1. Now here's the thing though, if we're going to divide on one side, we have to do the same thing, not only to just one part of the other side, but the entire other side. So if you're going to divide by 2 on one side, you've got to do it throughout the problem. So as we said, 2 divided by 2 is just a 1, or in this case just a y, 1y. A 1/2 divided by 2. We could do it by hand, but if you've got a calculator, especially a graphing calculator, you can make it do the work for you. I like to always put the original fraction in parentheses. So when I put the 1/2 in parentheses, that tells my calculator, hey, that's a fraction. And then we're dividing it by 2. And when I do that, my calculator is programmed to give me a decimal. And we could put a decimal, but when we're working with slope, we really want a fraction. So I can easily turn that decimal into a fraction. I'm going to show you on here. If you hit math, and then the first option says fraction, so we hit enter, and then it's saying, do you want your answer as a fraction? Yep. So we hit enter. So what your calculator has done here is it's taken 0.25 and it has given it to you in fraction form. And what's cool is that it will always reduce the fraction to the lowest reduced form. 1/2 divided by 2 is 1/4. And then we've got our x, and then -10 divided by 2 is a -5. Now one thing I do want to point out here, 1/4 x, we could also see this written, this would be equivalent to x over 4. And you may be thinking, well, where did the 1 go, right? Because we had a 1 up top. The 1 is still there. It's just understood in front of that x. We could have the x on the side, or we could have the x on the top. These two are expressing the same value. Now what's important to understand is this is different from, I'm going to put, would not be equal to 1 over 4x. So notice I put the x on the bottom. This isn't wrong, and we do see and use it a lot. It's just a different value than these. These two are equivalent, this one's different. So that's a little sidebar, but I do think it's an important point to make. I always typically like to write the x on the side. That's just me. Let's go ahead with labeling our y-intercept now, because now we're in the right form. We've got our y alone, y equals mx plus b. So we're good to go. Our y-intercept would be our constant, our -5, or our b value. And then our slope would be, and it's already in fraction form, a positive 1/4. So let's go ahead and write what that would mean. So positive up top would be up 1, and then a positive in the bottom would be right 4 units. And let's go ahead and write our alternative way of moving as well. We could have a -1 over -4, which would be down 1 and left 4. Let's go ahead and graph this. So our y-intercept is -5, so we want to find -5 on our y-axis, right here. And then we want to move, let's start with this one, up 1, right 4. And then let's do our alternate, so down 1, left 4. Go back to the start, down 1, left 4. And connect our dots. In this problem, notice we've got 6 times y minus 4 equals 10x plus 14. When I look at this and compare it to our standard form of y equals mx plus b, it's definitely not ready to graph, because that y is over on the left side, but it's not alone. It's got a 6 in front of it, tied through multiplication, and it has a minus 4. We need to take care of both of those and move them over to the other side before we're going to be able to graph this. Even though it looks like we have an mx plus b, they're not quite ready yet, because we've got to take care of these values first. It might be tempting to go ahead and divide by 6, but we don't want to do that. If we've got an addition or subtraction, we want to take care of that first and then divide out the 6. So what's the inverse or the opposite of minus 4? It would be adding 4. And when we do that, -4 plus 4 is 0. So we can just say it cancels out. We can show that by marking through it. But if we're going to add 4 to this side, we also need to add 4 to this side. I don't want to add 4 to the 10x because those aren't like terms. In order for us to add a 10x and a 4, they would have to either both have an x or both not have an x, right? Both be constants. So we don't want to put it underneath the 10x. We want to put it underneath the 14 because that is a like term. 14 plus 4 would give us 18. And then we still have our 10x and our equals, and we still have 6y at this point. So now we just need to take care of the 6. And just like we did here with the 2, the opposite of multiplication, or the inverse of multiplication, is division. We want to divide by what we know cancels. And that would leave us with just a y. But then we can't just divide by 6, we've got to do it to every single part on this side. Every part gets divided by 6. So 10x divided by 6. If we had 10 divided by 6, it's going to give us a decimal. But if I hit math, enter, it's going to tell me the reduced fraction. 5/3 is our reduced fraction. And remember, we could put the x up with the 5, or we could put it on the side. We would not want to move it down to the 3. That would be something different. I like to just put it on the side. And then 18 divided by 6 would give us a positive 3. So now we're ready to state our y-intercept and our slope and go ahead and graph this. It's in the right form now. Notice my y is alone, and I've got y equals mx plus b, just like our standard form. So my y-intercept is a positive 3, and our slope would be a 5/3. Now, it's positive 5/3, so that would be up 5 and right 3. And then our alternative to that would be a negative 5 over a negative 3, which would reduce to the same. And that would be a down 5 and a left 3. Now we're good to go ahead and graph. Our y-intercept is positive 3, so we find positive 3 on the y-axis. And then our GPS tells us how to move from there. So we'll go first with 5 up, 3 right. So 1, 2, 3, 4, 5, and 3 to the right. And then we could go ahead and do our alternate. So down 5, 1, 2, 3, 4, 5, left 3, 1, 2, 3. On this page, we're going to discuss 2 special cases. And those cases would be if we had a horizontal line or a vertical line. There's an acronym to help us with horizontal and vertical lines. Now, I want to be clear, I did not come up with this acronym, but I love it, and I think they're great ways to remember. For our horizontal lines, we have the acronym HOI. And what HOI stands for is just a way to help us remember that if it is a horizontal line, that's our H, it will have a slope of 0. That's the O of the HOI. It's really a 0. And it looks like y equals a number. So when we look at an example like on this one, y equals -4, I can immediately tell that this is going to be a horizontal line because it looks like y equals a number. Notice that there's no x here, like in our traditional standard form where we have an x, so y equals mx plus b, there's no x. These are very easy to graph. We just have to plot where y equals -4. So when we look at our y-axis, we see that y equals -4 down here. So our y-intercept is -4. Our slope, remember we said a HOI, or a horizontal line, has a slope of 0. And a 0 slope is a flat line. And we can actually, I know this feels weird because this does not look like this. And on the other pages, that was kind of like the first thing we said was, is it in the right form? And you may be thinking, well, that's not in the right form. Here's the thing, it actually is. It just looks a little different. We could rewrite this statement to look like that. It would look like y equals, and then our slope, remember our m we said is 0. We could put a slope of 0, x, and then our plus b would be our -4, so -4. These two statements are the same equation. They're the same line. It's just that we're applying this principle that 0 times anything is just 0. It doesn't matter what x would be. This would always reduce to 0. So what they do is they say, well, we don't really have to show that. It's implied. So we can get rid of that part and just have y equals -4, like we see there. Vertical lines are a little bit different. So for vertical lines, we have the acronym VUX. So a lot of times you'll hear teachers say HOI VUX, and it's just a way to remember horizontal lines and vertical lines. VUX stands for vertical line, that's the V, and then the U stands for that they have an undefined slope. And vertical lines, or our VUX, looks like x equals a number. Notice, like in this example, we just have x equals 5. That is in standard form. It's a form of our y equals mx plus b. These also are really easy. We just need to find where x equals 5. And x equals 5, so this time we're looking on the x-axis because it's x equals 5. So x equals 5 right over here. And then we just want to create a vertical line right at that spot. And if we wanted to say, okay, well, what's our y-intercept? What's our slope? If we were asked for that information, think about our y-intercept is where we cross the y-axis. Like here, right here, we clearly crossed the y-axis at -4. Here, notice with this blue vertical line, we don't cross the y-axis and we never will, because this line is going to go straight up and down forever. It's never going to cross this y-axis. So if someone asked you what is the y-intercept, we would just say none. There is no y-intercept. And then the slope would be undefined. It's a straight up and down line. Thanks for watching. This has been Miss Smith's Math Tutorials.